Have you ever been typing a text and your phone just finishes your sentence? Or wondered how a search engine knows exactly what you're looking for from just a few words? Well, today we are pulling back the curtain on the incredible technology that makes all of that happen. I mean, it all really starts with this one question that, let's be honest, we've all asked ourselves at some point. How on earth does my phone know what I'm about to type? It feels like magic. But the answer isn't some kind of digital mind reading. It's actually a super fascinating field in computer science called word-level analysis. And we're going to break down exactly how it works piece by piece. So, what's the very first secret to teaching a computer our language? Well, you have to get it to see that words aren't just these solid, unchangeable blocks of letters. They're more like constructions. They're built from smaller, meaningful pieces. This whole idea is the core of a field called morphology. You can think of it like anatomy, but for words. It's all about studying their internal structure. You know, how all the different parts snap together to create meaning. And, this Lego brick analogy, it's absolutely perfect here. Words aren't just random shapes. They are built from these smaller pieces that click together in really predictable ways. And every single one of those little pieces carries its own distinct meaning. In linguistics, we call these tiny building blocks morphemes. Things like prefixes, un, or suffixes like ness, those are perfect examples. You can't break them down any further without them losing their meaning. They are, quite literally, the atoms of our vocabulary. And it turns out we use these morphemes in two main ways. The first way is called inflection. That's all about grammar. Adding an S to make cats, plural, or changing run to ran to show past tense. The second way, derivation, is even cooler. It actually creates entirely new words, like when you stick on the end of the verb teach, and suddenly you have a noun, teacher. Okay, so that brings us to our second secret. A computer can now see the structure inside a single word. But how in the world does it find specific patterns across a massive churning sea of text with lightning speed? Well, the answer is this incredibly powerful tool called a regular expression, or as most people call it, regex. It's not just a word. It's a special sequence of characters that lets a computer search for a specific pattern of text. I absolutely love this description. You can really think of it as the ultimate find and replace tool, but on steroids. It goes way, way beyond just looking for a simple word, to find really complex structures hidden deep inside the data. So, for example, just imagine a computer needs to scan this sentence and find all the email addresses. It can't just search for Gmail or Yahoo, right? I mean, there are literally endless possibilities. So what does it do instead? It uses a regex pattern, like this one. Now, I know, that looks like a cat just walked across your keyboard. But it's actually a very, very precise description of the structure of an email address. It's basically saying, look for a string of characters, then an @ symbol, then another string of characters, then a dot, and then a few letters at the end. And boom, here's the result. Because it's searching for the pattern instead of specific words, the computer can instantly find anything that matches that email structure, whether it's ever seen that specific email address before or not. Pretty cool, right? And that brings us to our third and final secret, which gets us right back to our original question. Okay, a computer can deconstruct words, it can find patterns, but how does it actually predict what you're going to say next? The key here is a concept called n-grams. Now, it sounds technical, but an n-gram is really just a continuous sequence of words. A computer analyzes billions and billions of these sequences from huge amounts of text to learn one very simple thing: which words tend to follow other words. The process is actually pretty straightforward. A model takes a sentence, like this one, and just breaks it down into every possible overlapping chunk. It looks at single words, which are called unigrams, then it looks at pairs of words, or bigrams, then triplets, trigrams, and so on. It does this to count how often each of those sequences appears out in the wild. And here's where it gets really crucial. The model then calculates the probability that one word will follow another. It's basically asking a statistical question. Okay, out of all the millions of times I've seen the word quick, what percentage of those times was it immediately followed by the word brown? But wait a second, this creates a huge problem. I mean, what happens when a model sees a totally normal phrase that just by pure chance didn't happen to be in its massive training data? Well, according to the math, the probability of that phrase happening would be 0. So the model would just assume that phrase is impossible.
which obviously isn't true. This is where a really clever statistical trick called smoothing comes in. It's designed specifically to solve this zero probability problem.
And the core idea behind it is kind of genius. Smoothing essentially steals a tiny, tiny fraction of probability from all the common phrases the model has already seen, and it redistributes that stolen probability evenly among all the phrases it hasn't seen. This way, no word sequence is ever truly impossible. It just might be very, very unlikely.
So let's put it all together now. We've got morphemes as our Lego bricks, we have regex as our ultimate search tool, and we have n-grams acting as our statistical crystal ball. How did these three secrets combine to power the technology we use every single day?
Well, these three secrets are the engines driving so much of our modern world. When your phone auto-completes your text message or fixes a typo, that's pure n-gram probability at work. When an app translates a sentence, it's using morphology to handle complex grammar. Speech recognition, it's predicting the most likely words from the sounds you make. And when a search engine ranks results, it's using regex and word probabilities to find the most relevant information for you. It's all connected. And that leaves us with one final and really fascinating question to think about. We've seen how machines can deconstruct and predict our language with just stunning accuracy. But as they get better and better at predicting the next word, are they actually getting any closer to truly understanding what we mean? That's something to chew on.